if we look at the screen, we can see our first signal, which is the yellow signal, is our input, okay, and it's at 1 volts per division, while the blue signal, which is our output, is at 5 volts per division. Okay, so we see that the output is scaled by 5 to be almost equal to our input signal, which means our output signal is about 5 times the input signal. And if we consider the ratio between ROF and RON, which is the gain, okay, we're going to be having that to be approximately 4.7. Okay, so we have ROF over RON to be 4.7, and remember it's inverted, so we have negative sign. So it means our input signal at every point will be amplified by approximately 4.7 times, but inverted. Okay, so here I have my LM358P op amp, okay, and it's connected in such a way that we have a buffer, a voltage follower. So down here we have our first pin, pin 1, all right, and that's our output. Pin 2 is our inverting pin, so we have our inverting pin connected to the output, okay, via a jumper. All right, you can see that. And then we have the input signal connected to our non-inverting input. Okay, so that's the signal we're expecting to see on our output, because this is a voltage follower. It's a buffer, so it's not supposed to amplify the signal. It's supposed to give us same signal that we give it, same signal at the input. All right, so I'm going to be using a dual power source. Okay, I have my power supply behind. I have 9 volts coming in from my power supply here, and I'm going to have to use this battery here, okay, as my second voltage source. So we have a 9 volts battery and 9 volts coming in from my power supply. Okay, let's turn on oscilloscope first. The signal is already connected to the system, so we can see the signal we have. This signal is on the non-inverting pin. Okay, it's our input signal. All right, so let's connect. Put on our power supply, send out 9 volts, and then with the 9 volts from the battery, we turn on our channel 2, and we can see we have the same signal. If we put them on the same level, see channel 1 and channel 2 are same signal. We have 1.23 volts peak for channel 1, 1.25 volts peak for channel 2. Okay, so this is basically how the voltage follower works. It gives us same signal which was put into it, okay, because it's not meant to amplify. The benefit of using the dual power supply is that we don't get to truncate our signal. As compared to the first video we did with a single power supply, you see that the signal couldn't go below the 0 line, okay, on the output. When we use dual power supply, we give the op amp the ability to go below the 0 level to give us the exact signal that it's receiving on its input. Okay, so I have my op amp connected here as a non-inverting amplifier. Okay, so we have our setup here, we have our oscilloscope here, okay, and we are operating a dual power supply. So we're powering our op amp with a dual power supply of 9 volts each. So we have our power supply, we have a power supply coming in from this point, okay, this red and the negative down here, giving us 9 volts, and we have our battery here, 9 volts. So we are connecting both power supplies in series to have 18 volts. Okay, all right, so we have our input signal here already. We can see it says it has approximately 1.23 peak voltage, then 2.6 voltage peak to peak, and we have it at 50 Hz frequency. So this is our input signal. On our second channel, we're going to have our output signal once we connect our power supplies. So let's connect our power supply. Okay, let me start with connecting the 9 volts battery and then turn on the other power supply of 9 volts. Okay, you can see we have this blue wave, this blue signal that is way bigger than the original signal. Okay, so if we reduce the ratio, we'll see we brought it down to 5. Okay, so this is, if you look at this for the yellow signal, which is our input signal, it's 1 volt per division, while for the second signal it's now 5 volts per division. For it to come to be almost the same size with the first signal, we have to bring it down 5 times. Okay, so it means that this output signal is 5 times, more than 5 times greater than the input, and that's because if you look, you will see even at 5 times, we still have the blue signal higher than the yellow signal. And then if we check it mathematically, okay, we have the peak voltage, the peak to peak voltage of the input signal at 2.54, and we have the output signal at 14.2. If we solve that mathematically to see how much amplification, we'll see we have approximately 5.5. Okay, so from our calculations and our resistors, we expected to have an amplification of 6, a gain of 6, but we have a gain of 5.5 practically here. Okay, and the difference is due to certain factors, but you see we are close to the gain of 6. Okay, so here we have our op amp, our LM358, and we're using it as an inverting amplifier. Okay, so let's see what happens when we bring in our power supply. Okay, first of all, we have our signal already on channel 1. We have a triangular wave, okay, 50 Hz, 2.5 volts peak to peak, 1.3 volts peak. All right, so we're using a dual power supply. We have a 9 volts power supply, which I'm turning on now, and then we have another 9 volts power supply coming from our battery. All right, so let's see what we have on the output. Okay, if we look at the screen, we can see our first signal, which is the yellow signal, is our input. Okay, and it's at 1 volt per division, while the blue signal, which is our output, is at 5 volts per division. Okay, so we see that the output is scaled by 5 to be almost equal to our input signal, which means our output signal is about 5 times the input signal. And if we consider the ratio between ROF and RON, which is the gain, okay, we're going to be having that to be approximately 4.7. Okay, so we have ROF over RON to be 4.7, and remember it's inverted, so we have negative sign. So it means our input signal at every point will be amplified by approximately 4.7 times, but inverted. Okay, so that we can see. Okay, if we look at this point here, we'll see that that's our peak, and our peak is about 1.27 volts for our input signal. Okay, and we see that we have this signal inverted on the output at that same point. It's completely inverted at that same point, so you see why we have a negative sign for our gain. Okay, but then this point is also a peak for the output, and we have that at 5.47. If we do the maths, we'll find out that it's about the same value with our calculated gain. If we make the ratio 1 to 2.5, you can see what we have. We have our output signal way higher than that. If we make it 1:1, we would have it clip. So that's why we have to bring it down to scale it to what we can actually read.